So, hello everyone, we are live on Twitch. Welcome to another session of recreational programming. So, today basically we'll be creating a maze solver in C using the DFS algorithm, that is depth first search. We'll be visualizing the maze, solving the maze using a Raylib, and we'll be using this algorithm, DFS algorithm. It is a popular algorithm for traversing and searching tree and graph data. Basically, we'll be using this. So let's get started. I'll put a new file here. So check the comments. Right. So first, I'll include the necessary headers here. Raylib, standard input output, standard library, stdio.h, stdio.h, string.h, and firstly functions, type of functions. So let's get the main function here. So this one, firstly I will explain the flow. Basically we will have a UI with a maze and the walls of a maze of some grid, and we have walls in the between. We have a start point and the end point. We basically have to traverse from start point to end point using a DFS algorithm. Basically, firstly, we have to design the UI for that. So we have to first create a maze, then we have to continue with other things like. So for this, we are using layer Raylib. So make a make file here. Make file. Compiling main.c. This is main.c. Output directory will be build/main and Raylib. Here. Build for if it does not exist. So creating it on one. For run, we'll basically first compile, basically build/main. So this will be the make file. Here, make run. So directory here. So let's start with the code. So first we have to make initialize a window, a Raylib window. So I'll first do that. So we have to define some constants. Define. So we will have a grid of something, some rows versus some columns, right? So basically we have max. We can simply use rows. Rows equal to 20, I think. So define also will be 20, right? So each row or column will have a grid, so we'll be defining a grid size. So define grid size will be, I think, 20. For now we'll be using 20. So we can use like define width as a string to be basically rows multiplied by grid size, right? So same edge will have height, to have for width we will be using calls, so calls, and for height we'll be using rows, right? So basically we have the constants. And now what we have to do is create an initializer window, init window, right? So basically width will be width, height will be the height, the title of the window will be missile. So set fps, I think 60 will be good, right? So we have run this. Now we have to run an infinite loop. While windows will close. For now we'll basically set the clear background to white. So let's try compiling it. So this window is here. Its color is not visible, so because we don't have to use beacon, we don't have to use beacon drawing lines in drawing, so we have to use this one, right? So we have this window, but I think it's very small, so we have to increase. We can increase the grid size, right? So we have this kind of window here. Basically, in this window, we'll create grids of the size. So first we have to generate the mesh and draw the rectangle there in Raylib. So I'll get a function here. Basically we'll get a code function, generate mesh, right? So we'll be calling this. For that we have to create a node, right? So basically create a structure here. Struct node. This one. So what we will have first? So first we have the position in action y, right? So at second we can have a boolean value to check if the grid is wall or not. So you can check bool wall. So if we it's a wall, so you can set it to true. So boolean is visited, or simply you can use visited for literals using for DFS. So pointer to next node, no, not next node, previous node. So node, I think parent. So what can we do here? I'm not sorry. So we have this kind of node here. So each grid will be basically a node. So we'll loop through each of the grids and make a node instance for it and set the parameters, right? So first we have to loop through each, right? What we have to do is, so we have to simply use for loop here. For and I equal to 0, I is less than number of rows, right? Number of so we can use number of rows plus left row with column, so another for loop, and j is equal to 0, j is less than calls j plus plus. Basically we have two loops, one for the rows and one for the columns, so we have to create this one, so we have to basically create a pointer here, so we can simply do node image for it is a two-dimensional, I think, which such else. So can I do just like this? So we'll have a node pointer to image a maze with something rows and columns. So right, so what we can do here is so what we can do is, so we can call this grid of I j will be using malloc, so malloc, so what it will contain is the node itself, so use like this, so create a pointer, so right, right, so I can use this right. What we can do is, so we have created node and we have to set the value of action y, walls, etc. right? So what can we do? We can simply what's happening, grid of I j x will be the basically x, so basically will be I, right? So grid of y will be j, correct. So roach basically means this one, so we'll be using rows versus columns, right? Let's check it later. Grid of j of visited will be false, grid of I j I, this will be random, so for var we'll be using the random numbers, so using random and 175 if this is equal to 0, so we can do this, right? So we can just type here next node will be the nothing, like null. Can we do this? And parent will be, so basically this one. So let's check here. So first we have to do void draw image. So we have to draw image for int integer is less than image plus. So for integer is less than calls plus plus here. So we have to draw a rectangle, right? Draw rectangle here. So draw rectangle. Oh, rectangle. So basically I into grid size. So same image j into grid size. Set the color to gray. I think set it to gray. But it with the width. Maybe set a grid size image one here. So grid size image one. Let's see how it works. So here we do generate image, change image one. We draw the image, right? So let's test it. So we have this type of grid here. So we have to choose different colors for wall and for the start position and end position. We haven't set that. So basically we have to do this, right? So first change the color for so basically I think this is a constant, right? So literal color. So what we can do is color equals to as white by default. So color here, right? Budget, for example. So it will not be small, so it is clear. So this one. So it will conditionally change the color if, right, grid of I and J wall. And then we change the color to, I think, brown. So basically this is the image. So we have set the gray color to the normal grid, and we have set the brown color to the walls, right? So we have to create start and end position, right? So create two node here. So we will have a start and end node, right? So basically what can we do is start node and node, and basically at first there will be null, right? So this node will not be a wall, and so we have to separate this one, right? Right. So basically after the loop we have to set start node equal to grid of what? Basically I can set to 0 or random value. So start, so basically 2 1, we can choose any of the numbers. So node will be grid of rows minus something to calls minus 1. So it is static for every compilation. So start node val will be false, right? So in node val will be false. Right, so this way we can have this. So what we have to check here is so let's see if grid of I and J will be start node, then I will basically set the color to blue, right? So let's see if grid of I or J will be in node, so we can set the color to red. So like this. So we have a start point here and the end point here, right? So we have to traverse from here to here using the DFS algorithm, right? For that stack is needed. So we have to implement the DFS now. So let's create a GitHub repo. So let's create a GitHub now. So basically the build directory. This so basically we will implement the DFS. So for that we need a stack first, right? And some of the function needed for the stack, like push pop functions, right? So what can we do for that? So basically we can create a stack of node. The maximum number of will be the rows in the columns, right? So we can create a new variable, global variable, which basically points to stack top one, and basically get some of the functions like push, pop, etc. Right? So basically create a new one. Print to stack rows multiplied by columns. Right? So and we will need an integer stack top. And basically initially it will be -1, right? So we have to create functions, helper function for stack. So void push will be doing pushing the node. So the node stack plus stack top will be the basically node, right? So this is our push function. I will create a pop function. Wait, pop. So pop will basically right. So first we have to check if the stack is empty, so we have to remove if stack top is already greater less than 0, then return none, right? So else return stack of node, stack top minus, right? So can do this. and after generating image, we can push them into stack, right? So push create. So basically now we have created a stack top and pushing to our function. So we have to check if the stack is empty, right? And the function. So a boolean stack empty. So return stack top is less than 0. Basically call this function is stack. So we just stack empty. So we basically have to move this one. So right. So we have this one. Now what we have to do, we check if it is in bounds. So we are going to create another function, is bounds, right? Basically it will be also boolean, right? So what can we do? Create a function, boolean, it's in bounds. So we have to do accept two parameters, int x and int y, three parameters. Check x is less than equal to 0 and x is less than equal to, so y is less than equal to 0 and x is, sorry, this is greater, x is greater than equal to 0 and x is less than roj and y is less than false, right? Dealing with this one. So now we have to create so what we have to do now is create a depth first search function. We'll basically apply the this algorithm and traverse from each node, right? So what can we do? So we'll now get a function here, void left, so check here. What can we do? So we have to check if the search is complete or not. So we have to create a new variable here, a boolean variable search complete. So we have to create like this. So by default it will be false, right? So if search complete, or basically if it's tag is GMD, so we'll basically return, right? Don't have to search. Now this will pop the first element, last in first out, right? So node current will be pop, right? So we'll be popping the last element of the stack, and I will be checking if the current is available or not on the stack, and if it is already visited or not. So if current and current visited, sorry, if not current or current is visited or current is val. So if any of the condition is right, so we will return, right? Return node. So after that, let me set the visited to true for the current node. So current visited this function structures. Issue now. So we basically check if the search is complete or a stack will be returning, and we'll be popping the last element from the stack, and we'll be checking if current, or if there is not the current, and if the current is visited, or if the current is a val, then basically we'll be returning that node. So we will set a visited to true, and we have to check if current node equal to in node. So this one, then we'll make the search complete equal to true, and basically we'll return, right? The node is the goal node, actually we have the goal node. So now we have to look, right? So first we have to check the direction of left, down, right. So int of dx, right? So this one, dx means x and y. We'll be using top, right, bottom, and left, right? So top will be, sorry, right will be 1, left will be -1. So for top we'll be setting 0, right will be 1, bottom will be 0, and left will be -1. So this is dx, and same for dy. Right, so basically top will be the -1, but right will be 0, and bottom will be 1, and left will be -1. Sorry, 0, -1, 0, 1, and 0, right? So we have the direction here, top, right, bottom, and left. So we have the direction. Now we have to loop through 4 direction. Since we can go to 4 directions, right? From our node, we can go to 4 directions. So we have to loop through the 4. So 4 int equal to 0 is less than 4. Right? It's less than 4. Plus, right? So with this, and we have to check if they are in the bounds, right? So I'll create a new variable int and x, right? So basically it will be the current of x plus dx of right. Similarly int ny equals current of y plus dy of I. So these are the coordinates, right? Next point coordinates. So you have to check if these coordinates lies in the bound. So if not reaching bound, so nx and ny will be in return. Ny return, basically return it. So the neighbor this the node, we create a new node neighbor equals to grid of I think annex, right? So check if the node is not 1. So if not neighbor, sorry, just the node is not, right? So if neighbor, if not visited, and neighbor is not wall, so basically set the neighbor parent will be the current, right? So this one, and push will be pushing the neighbor, right? So basically this is the flow, right? So like this. This is the actual algorithm we have to work on, right? So now what we have to do? We've changed the image. Now we have to draw the path, right? What we have to do is start from the in node and and we will be traversing back it. So do it like this. Wait, draw path function. Basically, do second node, and we'll traversing through the node, right? So nodes current will be the node, right? While current as the parent, and while current as the parent, and what can we do? Current nothing will be null. So we might not, and current which not equal to start. So you can basically draw a rectangle. Right. Will be the current of x, right? Current of x into the grid size. Similarly for current of y and the grid size, it will be the grid size minus 1. Similarly, grid size minus 1 and color will be will be setting the orange parent, current parent. Right. So this is the one check. So on the function out. So if search completes, so what can we do is path. So this has been green. Sorry. So we have here so I think we've done the oh sorry. I think we don't have to push it here, right? We simply push the node, start node initially. Okay, this is the path. So this is the path, but start from here, right? While traversing, we have to show the path. Right? So what we have to do. Concept, right? So while pushing, we have to draw a rectangle there, right? Can we do draw a rectangle here, neighbor, right? Neighbor of x, neighbor of y, grid size, grid size, send here the grid size, the grid size -1, so here grid size -1, and color this color. Do this. So what have we done, right? So let's check. We have generated an image, right? So we've set up the here. So you're calling the draw image function, right? So can we do, right? Get a color here, color, and color J greater fine J Y, then it's brown as it is white, right? So start node color. Currently, what is the color of the start node? Blue. And feed node color will be red, right? Don't need this one, so you can use here reader J. Alright, so what can we do here? Here we can read out so we can set the neighbor. Okay, neighbor color. Can we do this? So we have this one. can slow it. Can you do that? You sleep. Like this. So can you sleep here too? Right. So basically this one. I think it's behaving like DFS. Why is behaving like DFS? First, speed it a bit. The white here, this is the gray. But why do I think it's behaving like a BFS, not a DFS? So in DFS, we traverse to the end of the node, right? So instead of doing this, simply we'll change the color, right? So current color between like basically. Usually not working here. This depth first search, right? Vegetate true and look in the flow direction. Inbound. Being Royal number of parameters same. In my case, it doesn't make any sense. Right. So, using this algorithm, I think it's been DFS rather than DFS, right? This node is completed. This node is right. So right here, right? We are just checking the neighbor, right? So we're checking the flow direction. Right. So we're checking it is inbound. It's been here, right? So it's the path. What's the issue? Generating a image, rendering a image. I think we have to go down to deep for this. This is the path. There's some issue here. So I think today will be simply one day doing this, right? So I think we have to optimize it tomorrow. So in DFS, one node to the start node, then we choose a random node belonged in connected to the node. And basically, we traverse through the node to the last, to the wall or any other thing, right? So this one, or this is in the wrong way. So I have to check this. So if not found, then we have to come to the parent, right? Last parent from where the another tree is being made, where the branch is being made. So we have to traverse through this. We have to continue this process, right? So basically, this is a DFS, right? But it's not doing it like this. So I think we have to check this, right? So that means for now this is fine, but tomorrow we have to update the logic, right? We'll be doing that. So nodes stack DFS. So I think this much for today. We'll be optimizing this one logic, the DFS logic, because currently it's working as a BFS, not a DFS. So tomorrow we'll be working on that. I think that's all today. Bye bye, guys.